All right, this is the third FRQ on the 2016 BC exam. So here they said the figure above shows the graph of f, and then they tell you that g is defined by the integral from 2 to x of f of t dt, and this is a really classic fundamental theorem of calculus, second fundamental theorem of calculus problem. So the first thing I'm going to do before I even do anything else is I'm just going to say, okay, if g of x is the integral from 2 to x f of t dt, then that means that g prime of x is f of x times 1 minus f of 2 times 0. This is me doing the second fundamental theorem of calculus. And so that means that g prime of x is f of x. So I'm going to say that this is actually the graph of g prime of x. And that's going to help me with all the problems moving forward so that I can correctly interpret this picture in terms of g, because all of these questions are in terms of g, not in terms of f. Okay. So it says, does g have a relative minimum, a relative maximum, or neither at x equals 10? Justify your answer. So now that I have this stated, now I can go ahead and use this graph. So g prime of 10 is negative to the left of 10, negative to the right of 10, so there's neither. So g prime of x is negative as x approaches 10 from the left and as x approaches 10 from the right. There's a few different ways that you could write that, but just saying that it's negative and it didn't switch from negative to positive or switch from positive to negative is the reason why you don't have a relative minimum or maximum. All right. Part B, does the graph of g have a point of inflection at x equals 4? So if we look at x equals 4, the graph switches from g prime is increasing to decreasing, and that's a point of inflection. So I'm going to say yes, g prime switches from increasing to decreasing at x equals 4. All right, part C, find the absolute minimum value and the absolute maximum value. So for us to do that, we have to do the extreme value theorem, which means we're going to have to look at the ends. So I'm going to have to look at x equals negative 4. I'm going to have to look at x equals 12. But I also have to look at where the derivative graph switches from positive to negative or negative to positive. So I'm going to look at negative 2. I don't have to look at 2. I'm going to look at 6. I don't have to look at 10. So for the extreme value theorem, I'm looking at negative 4, negative 2, 6, and 12. All right, so g of negative 4 is 2 to negative 4 f of t dt. And if you notice, these are kind of in backwards order, so I'm going to go ahead and write that this is the negative version of negative 4 to 2 f of t dt. Okay, so I'm going to go back. I've got a lot of things to kind of label in my picture. So I'm going to go ahead and do that. There's going to be a lot of areas for us to find. So this area right here is 1/2 times a base of 2 times a height of 4. So that's an area of 4, but it's on the negative side, right? So that's negative 4. And then this triangle is the same shape, so 4, 4. I can go ahead and kind of split this up just in case I need to split it later. So area of 4, area of 4. Lots of 4s in here. That's kind of nice. That'll make things easier later. Gosh, lots of 4s. Okay. So there are all the different areas that I'm going to be working with. So now I'm saying that the area that I want is the negative version of -4 to 2. So -4 to 2 is starting here. It's -4 plus 4 plus 4. Okay. So those cancel out, and I get -4. Okay. Next, I'm going to say g of -2 is the integral from 2 to -2 f of t dt. And again, it's written in the wrong order, so I'm going to say that's the negative integral from -2 to 2 f of t dt. And then -2 to 2 is 4 and 4. So it's the negative version of 4 plus 4, -8. Okay, g of 6 is 2 to 6 f of t dt, and that's in the correct order from 2 to 6. So 2 to 6, if I look, that's just 4 and 4, so that's 8. And then I'm running out of space, but I'm going to go ahead and do it around the corner. So I'm going to say f of, not f, g of 12 is the integral from 2 to 12 f of t dt. Again, that's in the correct order, so I can just look at the areas. And from 2 to 12, I have 4, 4, -4, -4, -4. So I've got, I don't even need a parenthesis. 4 plus 4 minus 4 minus 4 minus 4. And so that gives me -4. Okay, so now I have an absolute minimum, I have an absolute maximum. The absolute minimum is -8. The absolute maximum value is +8. This work that I've done here is the justification of my answer, so I just have to say absolute min value is -8. Absolute max value is +8. Okay. The next question says, for the interval from -4 to 12, find all the intervals for which g of x is less than or equal to 0. I did this ahead of time just to make sure that I wouldn't make mistakes as I was making the video, and this is the one that like royally messed with my brain more than anything else. So I'm not going to keep flipping the paper back and forth. I'm just going to go ahead and do the work like right up here. But what I ended up doing on my paper, and you do not have to do this if this one does not hurt your brain as much, I ended up making a number line for myself. So I said like -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh gosh. 11, 12. Okay. Sorry, that was obnoxious. I had to do that because it messed with my brain too much. I was like trying to figure it out. All right, so -4 we know gives you a negative output. It gives you -4. -2 gives you -8. 6 gives you +8. 12 gives you -4. So I started off with those. And then after that, I was like, okay, so if I want g of -3, then that is from 2 to -3 f of t dt, which is negative version of -3 to 2 f of t dt. Don't worry, I didn't do this for all of them. But if I go from -3 to +2, I could see that this is +8 and this is less than +8. And then I knew it was the opposite version of that. So I was like, okay, this is 8, and then it was going to be like minus some smaller number. And so I said, okay, that's going to be negative. And then I switched it. I said, okay, now we're doing -1. Okay, so -1 to 2 is that area. That's overall positive, but it's the opposite sign, so that's going to be negative. And then I said, okay, 0 to 2. From 0 to 2 is an area of 4, which is positive, but it's the opposite sign, so it's still going to be negative. Did the same for 1 to 2, still going to be negative. 2 to 2 is going to zero out, so that's 0 exactly. Okay, so then after that, I was like, okay, now I get to switch back to kind of the normal version of finding the area, so these get a little bit easier. So then I said, okay, g of 3 is going to be the integral from 2 to 3 f of t dt. So from 2 to 3, that's a positive area. From 2 to 4 is a positive area. From 2 to 5 is a positive area because we're looking at areas right up in here. 2 to 6 is positive. 2 to 7 is mostly positive with a little bit of negative. That's still going to be a positive area. 2 to 8, that's going to be 8 plus -4. That's a positive area. 2 to 9, we've got 8 plus a negative that's a little bit less than 8. That's a positive area. And then when you get from 2 to 10, this positive 8 and this negative 8 completely cancel out. You get 0. And then when you do to 11, these completely cancel out, but you have a little bit of a negative area. So that is the work that I did to figure out the answer to D. Not the most time efficient, but you can see from the time of this video that it still was, you know, I wasted time on this, but it was still less than 15 minutes for me. So if I want all intervals for the graph for g of x to be less than or equal to 0, that was from -4 to 2, including -4, including 2. And then it was from 10 to 12. Now your brain might have handled that better than my brain, but that's what I needed to do to be able to get that one right.